Good morning, team. I've set you up in the back seat of our 2000 Suburban. The left rear door lock is intermittently failing on me, or I go to lock the car and the door doesn't lock. I want you to watch the door lock and see if it moves at all when I activate the door lock from the front. And as much as it moved the first time, the second go around didn't move it enough to lock the door. It does move, which suggests there's at least some electrical continuity, but we're facing the usual question: is it a mechanical issue or is it an electrical issue? I've got my bets on it being mechanical as a first effort, so we're going to take the inner panel of the door off, lubricate anything we can see, put it back together and see if we can get it working just with mechanical lubrication. This turns out to be a 7mm. Same thing down here. And then once you get it loose, then you lift it up. And there we go. Next step is there's some wires, so you need to undo the connectors that hold the wires on, then the door comes free. This connector's undone. And that one too. That's the front of the car, that's the rear car, that's the top, and that's the bottom. Let me take the opportunity to show you these hooks. There's one hook here, one hook here, 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 and here. Another one here. This is the prominence where you do the door lock. This is the electrical connector here with another hook there, and a hook here, and a bolt hole here. Pretty simple. We'll hook up the electric interior light, the window up, down, and the door lock. We should be good to go. I must say that plastic tabs are the bane of my life. This one was a little hard to get off, especially given that I was trying to hold the door and undo it, and so I ended up disconnecting it here by accident, which could have been a problem if I'd lost some of those little parts, but I seem to be okay. Now let me show you how this goes together. There's just a single plastic tab there, so you got to push that one plastic tab in. Now the catch is that this is the inside of the door, so you can't see it until it's apart. It's hard to tell how it works, but hopefully having shown you this, it'll be easier for you when you come up to that problem. Look for the connector, press in the plastic tab. It's simple enough, but just a little bit sticky. So the mechanical part of this is here, and it feels stiff. So let's take some of this plastic off. There are generally two phases to this kind of thing. The first phase is the cleaning phase, where you clean all the dirt off with something like WD-40 or brake cleaner. And then the second phase is the lubrication phase, where you use something longer lasting like a silicone spray that lasts longer for lubrication. Consider it as two different cleaners for two different indications. Okay, that should be enough. This is WD-40. We're in the cleaning phase. I never use WD-40 as a lubricant normally because it doesn't last long enough, but as a cleaner it's excellent. Oh, that's way easier. We're getting there. Now we'll start with silicone lube. Now let's put the plastic back on. This is a weather sealer, so you want to try and keep weather out. When you have the windows open, water gets down into here and can cause real problems over the long term. So it's nice to have this weather sealer here. When I took the door off, I wasn't careful enough and I took off this electronic part rather than taking off the connector. And this electronic part has a little rubber top to it. And this is the part that controls the window. Got power on now, of course. And it's functioning normally, so we'll get that back together again. So really two connectors. This one's the light for the door, and this one's the window up down. And this is a mechanical connector for the lock. Let's put it back together again and see if it works. And if you do make the same mistake I did where that connector comes off, make sure you don't lose these little push pins. They go right here and right here. And of course that means it has to be assembled upside down because you don't want these things falling out. So one of the basic principles of good engineering design is to design things so that they can't be put in backwards. And you notice there's a chamfered corner on this side and sharp corners on this here. And that corresponds, the sharp corners there and the chamfered corners there. So it looks to me like this goes in this way. Now the other thing is, I should point out the tab for the connector is inside. Now the tricky thing here is to get that metal prominence lined up with this door lock here. Got the handle in. Feel the door lock right there. Okay, I think we have it. We can lock it manually. Lock. Unlock it. And lock it. So it was a mechanical problem after all. Well, that was simple enough, but what if lubrication doesn't work and you think it's an electrical problem? These wiring circuits can be really complicated, so you want to use a method that can quickly reduce your workflow and isolate the problem. As much as possible, I try to find a connector right beside the end device so I can test there and quickly show which side of the connector the problem is on. Of course, the first step is to look for power and ground at the connector when the switch is turned on. But then to assess circuit resistance, you need to somehow get electrons moving. That could be as simple as jumping the switch circuit with a test light, or as complex as a formal drop test with a 25 ohm resistor. Now, if I think the end device is bad, as a last check, sometimes you can wire it directly. Here in a different repair, I'm supplying power and ground to the window motor to get that window up while I wait for a new switch. Oh crap, I just locked myself out of the car. It's a good thing I have a spare key. So if this video helped you out and you want to see more of them, hit like or subscribe or leave a comment. I'd love to hear what others say. Thanks for watching.